Hi, so I'll be modeling how to navigate my lesson plan for the SIOP lesson assignment. So the lesson title is called Transformations, more specifically Reflections, and it's part of a larger unit titled Exponential Functions. So this is part of a 2-week series, and this lesson will probably be at the end of week 1. So students are continuing their series on transformations, and by this time they would have learned other types of transformations such as vertical and horizontal translation and stretch and compression. So the reason I chose reflections as last is because it tends to complicate things, and at this point students will be dealing with all types of transformations, not just reflections. So in a way, it's sort of review plus added material. But technically, they've been dealing with transformations with other types of functions in general, so the entire unit should not be completely new. The lesson will begin with students completing a warm-up, and the warm-up is supposed to be reminiscent of their geometry as well as Algebra 1 or even first semester of Algebra 2. So regardless of whether they've been exposed to this, whether they master this, the activation of prior knowledge can vary from students revisiting the concept, being reminded, to them relearning it, or just, discovering something on their own in class today. But I'm going to be focusing on the guided notes section because I just wanted to show this was where I tried to be most inclusive and conscious and aware of the language needs and the special accommodations. So that's what I kind of wanted more feedback on. But we'll start the lesson from here. So let me have your attention, please. So we're going to be describing transforming exponential functions today. And just like we did in the previous lessons, we're first going to start out by simply describing, right? We're going to describe what is happening to the function. And once we're comfortable with that, maybe we will sketch it if necessary. So, first, before we can start, we need to establish our main function that we're going to be transforming today. Now, technically, guys, this is not a parent function because our parent function has the form f of x equals a times b to the x. Notice there's a plus something here, so there's already a transformation happening in this function, right? So I put the 1 here for you guys, but it shouldn't be necessary, right? Okay, so we still are going to call this our base function. And this is going to be modeling what's happening. So technically, that means in this case, our parent function, right, let me call it p of x, is equivalent to 2 to the power of x, all right? But at this point in our series, hopefully we are comfortable with just graphing this as is. So when we do the text box describing the transformation, we're talking about this parent function here. So the parent function, 2 to the x. So let's see. What is our a? Our a is 1. What is our b? The base of our exponent is 2. What is our y-intercept? Well, what happens when x becomes 0? 2 to the 0th power, or any number to the 0th power, is 1. Plus 1 should be 2. What is our asymptote? Well, our usual asymptote is y equals 0. There's a vertical translation here, so we know that our asymptote has to been shifted up once. Our domain does not change. But because it was vertically translated, our range does change. Okay, and I know our range is greater than because a was not negative. Okay, so I guess I can fill this part in. 2 to the negative 1 is negative 1/2, plus 1 should be 0.5. 2 to the first power is 2, plus 1 is 3. 2 squared is 4, plus 1 is 5. Okay. Before I fill this in, do I feel comfortable writing this? I think so. Well, we already discussed this here, right? There's the only difference between the left and the right. There's no H here. That means there's no horizontal translation. However, there's a K here, right? The K is the 1 here, which is the asymptotes 1. So we know that it was translated vertically because it's K. And how many units? It's 1 unit. And which direction? Vertical can be up or down, right? So here we don't need the S. All right. So let's plot that. So I sketched this graph here for you, and hopefully you'll recognize, you'll recognize that this entire graph has moved up from the previous line here. And we can see how our horizontal asymptote of y equals 1 right here. So let's see how this function changes. So looking at this one here, now let's consider this function. What is the difference between our previous, let me make this bigger, right? What is the difference between this function and this function? Right? And you should notice that there is a negative here. So let's find out what happens. This time, instead of doing this first, since we're not sure about how the transformation will change our function, let's do it the old school way of just completing the table of values to find out what's happening for ourselves. So when I substitute a negative in here, 2 to the power of negative 1 is 1/2. We take the negative of that. Negative 1/2 plus 1 is positive 1/2. Okay, do something similar. 2 to the power of 0 is 1. Take the negative. Negative 1 plus 1 is 0. Negative 2 plus 1 is negative 1. Negative 4 plus 1 is negative 3. So let me quickly plot these really quick. So I plotted the points and connected the lines, and this is what we have. Okay, so you guys can kind of see how this line, there's a horizontal asymptote here. And that looks to be about y equals 1, and that makes sense, right? Because if we look back on our exponential function here, our k is still 1. So we still have a horizontal asymptote at y equals 1. Based on this and our chart, it looks as if our y-intercept is 0, 0. Okay. Our a, just like in this case, seems to be 1. However, there is a negative. So we have a negative 1 for a. And our b seems to be the same. So just based on that alone, it seems like the only thing that changed is my a. A went from 1 to negative 1. So looking at this, we know that unless there's a vertical translation, the domain does not change. So I will write it as all real numbers here. Then looking at our graph, our range is what? Well, we know it has something to do with 1, and our range is y. So what goes in between here? Is the graph facing up or down? It's facing down, so it's going to be less than. So let me ask you now that we have put all this information put together, how can we compare this function to the parent function, 2 to the x? Well, the parent function, 2 to the x, has been translated. What kind of transformation took place? So remember, I just reminded you guys that the only difference between these functions is this a, right? Everything else is the same. That means essentially everything that happened here still holds up, but there is something additional done to it. So let's consider what already happened here. We know that this function has been translated vertically by 1 units, and it went up and this time there's something extra to it, right? And it's been reflected. So let's compare. Which axis did it reflect about? Is it like this, or is it about the y-axis that way? It should be the x-axis. So what does this tell you? When a is negative, it doesn't have to be -1. It can be any kind of negative, right? This is an example of an x-axis reflection. We say that the parent function has been translated vertically by 1 units up. That's because we know our asymptote is now y equals 1 rather than y equals 0. And it has also been reflected about the x-axis. So if this was a growth, now this is a decay, because we read the graph from left to right. So let me give you guys a few minutes, and I would like you guys to try this function out on your own. And I'm going to slowly fill in this parts for you, and let's discuss what happens. So now that you guys have had some time on your own, let's see what's happening here. Let's do the same thing and compare it to this function that was already vertically translated up, right? Looking at our new function, the only difference now is that this x is now negative. So that means everything else should be the same, right? So I can fill in that a equals 1 because now there's no longer a negative in front. Okay, our b is still 2, right? And let's see, does our y-intercept change at all? 2 to the power of -0 is still 2 to the power of 0, so it should not change. Okay, so 2 to the power of 0 is 1, plus 1 is 2. So it's looking very similar to our first function right now, right? Almost looks identical, actually. So using our general form of the function again, we know our asymptote is y equals 1. Then our domain, once again, should not change. However, our range might. So I'm going to keep this open because I don't know what it's going to look like, right? And since I'm not quite sure what kind of reflection this is. Oh, wait. You guys know what the kind of reflection is? How did you know? Oh, well, I see. So there are only actually 2 types of reflections, right? This is called, and we just found out that when a is negative, it's called the x-axis reflection. So we can expect every graph we see to be flipped about the x-axis or some kind of horizontal line. So then